Alright, let's look at example 4.19. Proton moves in an electric field such that its acceleration is measured by this equation. So A equal to negative 20 times with 3 plus 4t to the power of negative 2, where t here is in second. So in any given second, right, we'll be able to measure the acceleration, right, just by substituting the value of t here. Now they want us to find the expression of velocity as a function of time if when t equal to 0 the velocity is equal to 20. Right, what does this mean? T equal to 0, velocity equal to 20. In other words, the initial velocity of such things of proton is 20. Okay, even as an initial velocity, right? So let's try to solve it. First, of course, we are going to extract every information available in this question. Okay, we have the acceleration in this function, and then they give us when t0 the initial velocity is already 20 centimeter per second, right? So what is the expression of the velocity? What is v? So of course, to find v, we know that a here is the second derivative of a function, where the first derivative is the velocity. So from acceleration to go to velocity, we'll need to integrate once. So let's integrate the function of acceleration, right? Okay, so notice that to integrate it, we'll need to use the substitution. So this is defined as u, right? Automatically this is the form, the u form, and of course we differentiate the u, we'll get 4, and we'll need to, at this point we'll need to change dt into u. So dt equal to du over d4. So at this point everything should be in u terms. Okay, substitute dt du over 4, and notice that everything is in u form. Simplify it, this is the final u forms. Okay, after we have obtained this, next thing to do is to start integrating the function. Okay, u negative 2, integrate it, become u negative 1 over negative 1. Simplify it, right? We'll get 5 times u negative 1 plus c. Expand the u, this is what you get. Now, in terms of indefinite integration, this will be the final answer. However, as you may already know, we can't really leave the question like this, because we still have another unknown value here, c. Unless we solve for c, this function will be unusable. So let us solve for c by using the available information. We know that in a situation of t equal to 0, right, the initial velocity, right, I said it as an initial velocity because there is still, the time still hasn't moved yet. So v equal to 20. So we can substitute this information of v and t, right? Solve for the c, and we'll get c equal to 18.33. Next thing to do is to substitute c back into the formula. Okay, now we have the complete velocity function. So this plus with previously known as c, 18.33. However, this is not the precise function, because as you may realize, 18.33 is not all the numbers for c. So in terms of engineering, it is wise to to bring every point. So the most easiest way for us to bring every point is by converting it into a fraction, which is 55/3. Alright, and don't forget the scale. So this velocity, alright, is, look back at the question and you'll notice that the velocity is in a centimeter with respect to time in second. Right, so this is the velocity function. Okay, thank you.